Namaste friends. In today's Chemtonics, named reactions in organic chemistry I have taken from NCERT only. I have not added any other reaction other than NCERT. So class 11, nothing but in Karnataka, PUC first we call it as, that I am going to discuss. So whatever the reactions are there in NCERT I have taken. If I miss any of the reaction, that you have to take it from the textbook, you can read. Yes, first one, Wood's reaction. See, Wood's reaction, what you have to remember? Wood's reaction means you have to remember in your mind, sodium in dry ether, alkyl halide converted into higher alkane. Very simple. Wood's reaction means sodium in dry ether, alkyl halide converted into higher alkane. For example, see, RX, 2Na, RX, dry ether to form RR. So how this reaction take place? Very simple. X and 2Na you have to remove like this, so that R and R you can make a direct bond. So RR is going to get, that is nothing but alkane. For example, I have taken, see, 2 CH3 is here, and in product you can see CH3, CH3. This much it is very simple. So 2Na, Br is going to form. Very important is dry ether, remember that. Then, best method for the preparation of alkane it is. So, that to even number of alkanes. But what happens is, if you take two different alkyl halides to prepare odd number of the carbon compound, odd number containing alkane, then you are going to end up with mixture of products. So because of that reason, it is not a suitable method for the preparation of the other than even number of compound. Andre odd number of compound, it is not suitable. For example, I will give you one reaction. So in this particular case, for example, just imagine if you take CH3 Br reacts with C2H5 Br plus Na. So now, what all the product is possible? See, this react with another this only, because in any reaction practically only one molecule you cannot add. Remember that. So CH3Br is going to form first CH3 like this. Correct? Next to C2H5 is going to form, remember, C4H10 butane is going to form. Then what happens? You are going to get this plus this react together to form CH3 C2H5. This was asked once. Remember, these three products are possible plus NABR. Not necessary to balance the reaction. I have not write the balanced reaction. But here, what you have to understand is, if I take two different alkyl halide, I will end up with three products. Remember, separation of these three products is very difficult because they are very less difference in the boiling point. Hence, difference very difficult to separate. Hence, it is not suitable method to prepare such type of this alkane. So, even number you can easily prepare by using this. Once again, methane you cannot prepare, obviously, because methane means at least only one carbon atom. So, here you will start from 2 carbon atom, 2, 4, 6, 8 like that. This is Wood's reaction. Then Cope's electrolytic method. Very simple method, remember. So, solution of sodium or potassium salts of carboxylic acid undergo electrolysis. So, undergo electrolysis, you are going to get, so, alkane like this. Once again, here also remember, only even number you can prepare. Only even number you can prepare. Methane cannot be prepared. Methane cannot be prepared from this. So, minimum 2 carbon atom. See, product how it is forming. So, 2 NaOH is forming. Na and OH, NaOH. So, H2 at cathode, CO2 at anode is released. Very important point. H2 at cathode, CO2 at anode, it is released. Mechanism not necessary to know. But generally H plus is there, so hydrogen definitely evolved at cathode, reduction take place and oxidation take place at anode. See, RR is going to form. Then from this, remember, alkene and alkyne also can be prepared. So alkene and alkyne, how it is prepared? See, alkene to prepare, what you have to do is, you have to take CS2COOK, CS2COOK, such type of compounds, remember. So you have to consider dicarboxylic acid. In water, you are going to get, after the electrolysis, you are going to get double bond. See, very simple. Here there is no bond, it will form a bond, one bond. Here already one bond, it will form two bonds. Here already two bonds, it will form three bonds. Remember that. So once again, CO2 and H2 same, anode and cathode. Here also CO2 and S2, and potassium I have taken, so KOH, sodium I have taken, so NaOH. This is a Kolb's electrolytic method. Then decarboxylation. This is not the named reaction, but I have taken very important antele. So decarboxylation, remember here, decarboxylation means you have to remember in your mind soda lime. Soda lime, remember, soda lime is nothing but the mixture of NaOH and CaO in the ratio 3:1. Remember that. Now, that soda lime, when it is introduced to sodium or potassium salt of carboxylic acid. So here I have taken CS2CONA. So here what happens is Na and CO2 seri, Na to CO3 it will form. Na to CO3. Then CS3 plus H, it will form CH4. So once it was asked, Na to CO3, the carbon comes from where? Whether it is a soda lime or whether it is this one, remember from this it came forming Na to CO3. Similarly, so general reaction, sodium or potassium also carboxylic acid, soda lime to form alkane with one carbon less, remember. So here 2 carbon atom, here 1 carbon atom. Very simple, very important. So then isomerization I have taken because important once it was asked. Isomerization means here generally, so chain isomer to branched isomers we can consider. So chain isomer it is only. So normal N-alkane, that is long chain alkane, branched chain alkane is going to form. So remember it is catalyst, you have to remember AlCl3 in presence of HCl at 573 Kelvin and 35 atmospheric pressure. Isomerism means AlCl3 HCl. See, very simple. Wood's reaction, sodium and triether. Kolb's reaction, electrolysis, sodium salt of carboxylic acid. Decarboxylation, soda lime, NaOH, so carbon dioxide is removed, alkane is formed. So here N-alkane to branched alkane, AlCl3 HCl. See, write all these reactant, at least those who are preparing for 2021 exam I am talking about. Write all these, the catalyst or you can say reagents in one particular page, and you paste that page in front of you where you are sitting for study. Remember that. Then aromatization you can say. Aromatization, what happens is N-hexane converted into benzene. N-hexane to benzene, the catalyst to remember Cr, this or any of these you can take. Chromium oxide, vanadium oxide, molybdenum oxide, aluminum oxide. Any of these at 773 Kelvin, 10 to 20 atmospheric pressure, N-hexane to benzene can take place. N-heptane, 1 carbon atom more, hence it is going to form toluene here. So remember that. Then Lindlar's catalyst, named reaction. Lindlar's catalyst means what? Remember, Lindlar's catalyst means this should be remembered. H2 in PD and charcoal. H2 in PD and charcoal, palladium charcoal, supported over CaCO3 and BaSO4. So what is the use of this? Always alkyne converted into cis. Remember, alkyne converted into cis. Very simple. Alkyne converted into cis. So how you can remember this? See, we have to use some, you can say, whatever the method you can use, so you can remember it like that. For example, I will remember it like this. See, my method you may not like, but my method is like this. See, here charcoal is there, here charcoal is not there, correct? Charcoal, C, generally what we will write? We will write PD bar C, we will write Lindlar's catalyst. C is there, cis alkene. See, C is there, cis alkene. See, this type of C, we have very small mind. Thousands of neurons are there in which you have to remember these things. Means it's very difficult what to remember, how to remember anta bandaga. I will follow these methods. See, only 2 options we have, cis and trans, correct? So hence remember I will go for this PDC cis alkene like that. See, it's just like iga, in which case, so in RNA remember uracil is present, in DNA uracil is not present. How I will remember? See, I will tell you, RU, I will remember it as RU. See, RU, you are asking some question. RU means, so uracil, RNA, like this. So, like this, remember. So, here also I will follow the same. See, it is not the condition that you may feel that I am full. Yes, I am chemistry full, remember. Yes. C is there, so cis alkene. Remaining is only one trans alkene. So, Birch reduction is sodium or liquid, or you can say lithium also, no problem. Sodium or lithium in liquid ammonia. Alkyne converted into trans alkene. One is cis CC and another one is trans, like that. Then dehydrohalogenation reaction or beta elimination, or you can call it as Jeff's rule. See, this will comes under haloalkanes also. There I will not discuss once again. See, dehydrohalogenation means what? So D, hydrogen and halogen. D means remove. Hydrogen and halogen you are going to remove. So when dehydrohalogenation takes place, according to Jeff's rule, what it says, highly substituted alkene is the major product. Highly substituted means, remember, doubly bonded carbon atom should have least number of hydrogen atom. For example, you can say more stable I have taken major it is. So this one is major and this one is minor. See, here 2 hydrogens are attached to doubly bonded carbon. Here 3 hydrogen attached to doubly bonded carbon, which means which is more substituted? This one. Hence this is the major product. Once again, in this dehydrohalogenation means what it should come in your mind. Andre alkyl halide alkene. Very simple. Alkyl halide to alkene, reagent is alcoholic NaOH or KOH. It should be there in your mind. So alcoholic NaOH or KOH. So this reactant alcoholic KOH, major product is this alkene and minor is this alkene. Very simple dehydrohalogenation reaction. Then Markovnikov's rule. Markovnikov's rule is very simple. Unsymmetrical reagents. Unsymmetrical reagent means, remember, HX, H plus X minus, H2O, OH, H plus OH minus, HOX, so H plus OX minus, like that. For two unsymmetrical alkenes like this, unsymmetrical alkene, in such a way that negative part of the reagent, negative part of all this reagent, added to the carbon atom with lesser number of hydrogen atom. Carbon atom with lesser number of hydrogen atoms. See, HBr is there, correct? HBr, H plus Br minus. I have taken Br minus to the lesser number of carbon atoms, so Br, H plus to this carbon, so HCH3. Very simple. Important is, remember, carbocation intermediate. So intermediate formed is carbocation here. Then anti-Markovnikov's rule, peroxide effect or Karash effect also you can call it as. Now what happens is, the same reaction if I use peroxide, then it will catalyze this reaction through, remember, free radical mechanism. So this followed by, remember, this follows free radical mechanism. So free radical mechanism, remember that. So now what happens is, according opposite to Markovnikov's rule means what? So hydrogen attached to that carbon having more number of hydrogen atom. Here Br minus attached to that carbon which is having less number of hydrogen atom. Here Br minus attached to that carbon which is having more number of hydrogen atom. Br minus. So Br minus attached here, H attached here. So CH3, CH2, CH2, Br. Remember, with this also some amount of this you will get, definitely 80%, 20% like that. So plus this, and with this also some 20% of this also you are going to get, no doubt. But remember, main product I have written. So here Markovnikov's rule product, anti-Markovnikov's rule product. So very important, the effect is observed only with HBr. Very, very important point. Why? All these reasons I have explained in hydrocarbon chapter, that you can see. See, this effect is observed only when HBr is not with HCl and HI. Generally what happens, HI, free radical is going to form but immediately react with another iodine. HCl, difficult to break homolytically. So homolytical cleavage is needed for free radical. Hence remember, this effect observed when HBr is present. Then Bayer's test. Bayer's test is nothing but cold dilute neutral or alkaline KMnO4 we will take. This is the test which is used for unsaturation detection. Remember, alkene it will not react. So alkene and alkyne it can react. See, alkene I have taken, ethene reacts with this Bayer's reagent H2O in presence of nascent oxygen. You are going to get, see, like this, CH2H, CH2H. So glycol we will call it as glycol, ethylene glycol you are going to get. So in this course of reaction, remember, KMnO4 color decolorizes. KMnO4 decolorizes means almost violet color, it will decolorize. Remember, that is unsaturation test. Then ozonolysis. Ozonolysis means, remember, it is used to detect the position of the double bond. Very simple. And detailed ozonolysis I have explained in case of the hydrocarbon chapter, that you can refer. Fine. Double bond or triple bond. So generally what happens when ozone react with this, forming ozonide with zinc and water, HCHO, aldehydes, or sometime it is ketone. So remember that. So here reductive ozonolysis it is. So if you don't use this water, then you are going to get HCOH. That is oxidative ozonolysis. See, for our NCRT only reductive is there, hence I have taken this. So this CH2 double bond CH2 ozone how it is added, you see, removed this particular double bond is removed completely, oxygen 1 here, oxygen 1 here, oxygen 1 here. Then zinc bar water, that is in presence of zinc and water, you are going to get HCHO. So formation of aldehydes or ketones from this particular reaction. Then how to write the product? Very simple. Already I have told the technique also. Very simple, easy to write the product. What you have to do? You have to cut this molecule into two. Right? One oxygen here, one oxygen here. Very simple. So I have not written ozonoid formation here. Directly product I will write. So now what is the product now? CH3 double bond plus C double bond CH3 like this. So question what they will ask? So by giving these product, which is the alkene they ask, right? By giving these product, which is the alkene you will get. That's the question they will ask. So in such case, what you have to do? You have to see reverse it. So that also technique I have explained in hydrocarbon chapter that you can see. So if you want these colorful notes, once again I will tell you. So Telegram app, so link is given, join Telegram group, so that almost 1000 students are there in that group. So you will get all these notes which is already uploaded in the group, right? So like this ozonolysis take place and forming aldehydes or ketones. Then two reaction. So in aromatic reactions, Friedel-Crafts reaction are considered. See, Friedel-Crafts reaction, what happens is introduction of alkyl or acyl group into arene. So arene means benzene group it may be, or you can say aromatic compounds like toluene or this chlorine, chlorobenzene, nitrobenzene, all this. First one, Friedel-Crafts alkylation. First of all, remember Friedel-Crafts, which means who should come into your mind? Anhydrous ClCl3. Who should come into your mind? Anhydrous ClCl3. Very, very important. So Friedel-Crafts alkylation, where alkyl chloride is used. Haloalkane is used. Electrophile is R plus, remember R plus, here it is CH3 plus C. Now benzene, when it reacts with CH3Cl, so anhydrous ClCl3 in presence of, you are going to get R plus as electrophile, CH3 plus as electrophile, and you are going to get this particular product. Very simple. The CH arene, that is benzene, in which CH3 group is introduced, that is called as Friedel-Crafts alkylation. So similarly Friedel-Crafts acylation. Friedel-Crafts acylation, what happens is electrophile is RCO plus. Electrophile is RCO plus. That is acyl group, remember. So reagent is once again RCOCl in presence of anhydrous ClCl3. RCOCl is removed, so C plus charge on the carbon, this C double bond of carbon. Now very simple, once again, this bond is undergoing cleavage here, so that C plus will attack on this carbon. So hence you are going to get acetophenone. This is the name of this is acetophenone. Remember, acetophenone. You are going to get anhydrous ClCl3. So this Cl is removed. This is acylation. Now addition to these two, which means this is not only for benzene. This is possible for all those substituted benzenes. In substituted benzene cases, what happens? I have given one example. See, if I just imagine I have taken substituted benzene, X is substituted. Here X means not halogen. Any compound you can take, any group, plus RCl in presence of AlCl3 forming ortho and meta product. See, very simple. RCl, alkylation first I am talking about RCl. So R attached to ortho position, R attached to para position. This is not meta here. This is para position. Remember, para position. Right? So now, very simple. If that X is electron with donating groups, this reaction is possible only when X is electron donating groups like chlorobenzene, phenol, anisole, aniline. In all these cases, Friedel-Crafts alkylation, you are going to get ortho or para. So generally in aniline it does not undergo, because in aniline what happens is AlCl3 is Lewis acid and NH2 is Lewis base, hence it will react with each other. But I have taken example of electron donating groups. Fine. This alkyl halide, this haloarenes, I can say X if any electron donating group. Whenever electron donating group is there, it is activating benzene ring towards electrophilic substitution reaction. This is electrophile, hence it is called as electrophilic substitution reaction, and the product is ortho and para product. If this X is, remember, electron withdrawing groups like NO2, CHO, COH, remember, then you are going to get meta product. Very simple. AlCl3 anhydrous, you are going to get meta product, RCl. Similarly, RCOCl. Similarly, RCOCl also, you will get a COCH3 here, or COCH3 para position. Here you will get COCH3 meta position. So I will not explain this reaction once again in the second PUC part, because already here I have completed. Friedel-Crafts reaction means what you have to remember in your mind: anhydrous ClCl3. That is very important point. Electrophile is R plus nothing but CH3 plus. Remember that point. Very important, very simple. These are the reaction which I felt that it is present in the class 11th, so or PUC first year. So PUC second year, so still I have to make a notes of that. I have written like this, so I will come up with the PUC second year reactions as soon as possible. So thank you for watching till now. So if you are not subscribed to my channel, please subscribe to my channel. So for the materials like this, very best materials I will give you. Then if you are not shared to your friends, please share to this to your friends also. Thank you. Have a nice day.